Imagine this. You are sitting inside one of the most modern electric cars on the market. The kind of car that just a few years ago you were probably dreaming about because it had the most advanced technology of its time. A huge screen, a powerful battery, smooth acceleration. You are happy with it and you believe this is the future. Then suddenly, one evening you open YouTube and watch a clip of a very familiar public figure saying, "The thing you are driving right now is already outdated." Elon Musk, the man who was once laughed at when he said he would sell tens of thousands of electric cars every month. The man who was once called crazy when he said he would send humans to Mars for a second time. And almost every single time, he proved his critics wrong and showed that the things he talked about could actually become real. So what is Musk talking about this time? He has just hinted at a completely new kind of engine technology. Not a small improvement, not an upgraded version, but an entirely different propulsion mechanism. Something that, according to many people who closely follow Tesla, could be described as an electric jet engine. Does that sound like science fiction? Maybe. But remember this. Lithium batteries were once science fiction, self-driving cars were once science fiction, and SpaceX reusing rockets was once considered impossible by almost the entire aerospace industry. What makes this announcement especially dangerous for Tesla's rivals is not just the technology itself, it is the timing. While General Motors, Ford, Volkswagen, and dozens of other brands are spending billions of dollars trying to close the gap with Tesla in the traditional electric vehicle race, Musk seems to be preparing to change the rules completely. He is not just trying to run faster on the old track. He is trying to open up a brand new track that no one else is ready for. But this is what makes the story truly fascinating. No one knows for sure how this technology actually works. No one knows when it will really appear on public roads. And more than a few experts are asking whether this is a real revolution or just another flashy performance from a man famous for making huge promises. So, what makes this technology different from everything that came before it? Why should Tesla's rivals be this worried? And could this be the real turning point for the global electric vehicle industry? Or is it just another big promise waiting for time to judge? That is exactly what we are going to explore together in today's video. Before we dive deeper into the story, if you enjoy in-depth analysis like this about electric vehicle technology and the engineering breakthroughs that are reshaping the future, do not forget to subscribe to the channel and turn on notifications so you do not miss the next videos. When the electric vehicle race is reaching its most intense moment, to understand why Elon Musk's latest statement caused such a shockwave, we need to step back and look at the bigger picture of the global electric vehicle industry over the past several years. About 15 years ago, electric cars were something most people only saw in short news segments at the end of the day, or at technology exhibitions where everyone nodded and praised the idea, but almost no one actually believed they would drive one home. The batteries were weak, the range was short, charging infrastructure barely existed, and the price only made sense for a very small group of people. Back then, electric cars were a good idea, but they were not yet a practical product. Then Tesla appeared and everything began to change in a way almost no one expected. The Model S was not just an electric car, it was a statement. For the first time, an electric car was not only clean and efficient, but also beautiful, fast, and fun to drive. Its driving range crossed an important psychological barrier. Autopilot made people start thinking seriously about an autonomous future. And the giant touchscreen in the middle of the car made the interior feel like something that had stepped out of the next century. Tesla was not just selling cars. Tesla was selling a vision. And millions of people bought into that vision. But here's the interesting thing about major markets like the United States. Once an idea has been proven possible, the giants start waking up. General Motors, the company that once stopped production of the famous EV1 in 1999 and was heavily criticized for it, began rebuilding its entire strategy. Ford announced multi-billion-dollar investments in electric vehicles. Volkswagen set a goal to sell millions of electric cars every year by the middle of this decade. Even Toyota, the world's longtime hybrid leader, was forced to announce a much broader shift toward electrification. And that does not even include the completely new players. Rivian came in with powerful electric pickup trucks. Lucid Motors pushed range to record levels. And in Asia, especially China, an entire domestic electric vehicle ecosystem is rising at an unbelievable speed. BYD is no longer only competing with Tesla in the affordable segment, it is moving into the premium segment. NIO is building a battery swapping network instead of relying only on charging. Xiaomi, the smartphone giant, just launched its first electric car and sold out within minutes. The race is no longer Tesla running alone. And this is the key point you need to understand if you want to feel the weight of what Musk just announced. In such a brutally competitive environment, when dozens of brands are throwing tens of billions of dollars in the same direction, Tesla's advantage is slowly shrinking. Not because Tesla's getting weaker, but because the world is quickly catching up to what Tesla built over the last decade. Software, range, charging systems, premium interior design. All the things Tesla once had almost to itself are now becoming industry standards. So if you were Elon Musk and you see the crowd catching up with you on the old track, what do? You change the track. But to understand why this announcement matters so much, we need to look straight at the heart of the whole story, the technology itself. What is an electric jet engine, and why is it completely different? First, let's be clear about one thing. Calling this an electric jet engine sounds dramatic and attention-grabbing, but it is actually describing an engineering principle with a very real foundation. We are not talking about a car with wings, and we are not talking about something that breaks the laws of physics. We are talking about applying the core operating principle of a jet engine, combining it with electric power, and creating a completely different kind of propulsion system. Let me explain this in the simplest way possible. A traditional electric car, including today's Tesla vehicles, works like this. A lithium-ion battery stores electricity. That electricity is sent to one or more electric motors, and those motors directly turn the wheels through the drivetrain. Simple, efficient, and already proven. That is why modern electric cars can accelerate so quickly, because electric motors deliver instant torque from the moment they start, unlike internal combustion engines that need time to build pressure. But this system still has one basic weakness. The entire power and range of the vehicle depends completely on how much energy the battery pack can store. And that has been the biggest bottleneck in the electric vehicle industry from the very beginning. The bigger the battery, the longer the range. But the bigger the battery, the heavier the car. The heavier the car, the more energy it needs to move the same distance. This is a vicious cycle that has frustrated engineers for decades. And then there is charging time. Even though fast charging technology has come a long way, an electric car still needs at least 20 to 30 minutes at the fastest charging stations to take in enough energy for a long trip. Compared with around 3 to 5 minutes to fill up a gasoline tank, that is still a real psychological gap for many drivers. Now think about how a jet engine works. In a traditional jet engine, air is pulled in, compressed to extremely high pressure, and then fuel is burned to create powerful thrust. Most of that thrust comes from high-speed air shooting out the back, not from friction with the ground. That is why airplanes do not need wheels to keep moving once they are in the air. They are being pushed by air. The idea Musk appears to be pursuing is a system that pulls in and compresses air using electricity instead of fuel combustion. If successful, this could create thrust without depending completely on wheel friction. And here is the interesting part. A system like this could theoretically operate with a much smaller battery pack because it would not need to store enough energy to spin the wheels across the entire trip. Instead, it would need enough energy to maintain a high-pressure airflow, a process that could be much more efficient under certain conditions. On top of that, because some of the thrust would come from air instead of entirely from the wheels, the vehicle could maintain more stable performance on rough surfaces. Rain, snow, muddy roads? Conditions that can seriously reduce the performance of regular electric vehicles might be handled better if thrust comes from air instead of only from the tires. At first, this may sound like just an interesting technical detail, but that small detail is exactly the kind of thing that could change the entire game if it can be done successfully. The real breakthrough is not speed. It is breaking free from the battery trap. Now we get to the key point that not enough people mention when they talk about this technology. When most people hear the phrase electric jet engine, they immediately think about speed. They imagine a Tesla launching from 0 to 100 kilometers per hour in less than 2 seconds. And yes, if this technology is successfully developed, that kind of performance is absolutely within reach. But that is not the biggest leap forward. The biggest leap forward is something electric vehicle engineers have been losing sleep over for the past 15 years: breaking free from dependence on lithium. Look at the supply chain of a modern electric car. To produce a lithium-ion battery pack powerful enough for a mid-range car like the Tesla Model 3, you need a significant amount of lithium, cobalt, nickel, and manganese. These minerals are not unlimited. They are not found everywhere, and extracting them leaves serious environmental damage behind. Cobalt is the clearest example. A large share of the world's cobalt comes from the Democratic Republic of the Congo, a country that already faces deep political and social instability. Reports about working conditions in cobalt mines have shocked the international public many times. Electric vehicle manufacturers, no matter how good their intentions may be, still depend on that supply chain. And cobalt prices can swing so sharply that one sudden price spike can wipe out the profit from an entire year of production. If Musk really can develop a propulsion system that significantly reduces the size of battery packs or removes dependence on large lithium batteries altogether, this would not just be an engineering victory. It would be a geopolitical victory, a supply chain victory, and an environmental sustainability victory all at once. A car powered by an electric air propulsion mechanism would need less battery capacity. Less battery capacity means less lithium. Less lithium means less dependence on problematic mining regions. And the entire cost structure of electric vehicle production could be rebuilt from the ground up. But there is a third factor that people talk about even less, and it is the one that could force Tesla's competitors to rethink everything from the beginning. If the basic propulsion mechanism of electric vehicles changes completely, then everything rivals have invested in optimizing traditional battery and electric motor systems may no longer be a major advantage. Billions of dollars poured into next-generation battery research and development could suddenly become investments aimed at a technology that may already be on the path to being left behind. This is exactly what happened when electric vehicles began to truly compete with gasoline cars. Manufacturers that had invested too heavily in internal combustion engines suddenly found themselves holding outdated weapons in a war that was changing. History may be getting ready to repeat itself, but this time with the very companies that benefited from the previous shift. Still, no matter how good a technology sounds, it does not matter if it cannot be produced at scale. And this is where the story becomes much more complicated. The challenges no one should ignore. Let's be honest, this is the part that many YouTube videos about Elon Musk tend to skip or rush through quickly before going back to excited praise. But if you really want to understand this story, you need to look at the challenges honestly. The first and biggest challenge is whether this can actually work in real-world conditions. The principle behind an electric jet engine is not baseless, but applying it to a real road vehicle, one that has to handle potholes, storms, dust, and the extreme winter temperatures of Minnesota or the extreme summer heat of Arizona, is a completely different engineering problem. Jet engines on airplanes are maintained under extremely strict schedules after every few hundred hours of flight. A family car needs to run for tens of thousands of kilometers with minimal maintenance, and it cannot suddenly fail in the middle of the road. Compressing air at high pressure requires highly precise mechanical parts. Those parts wear down over time. Temperature, humidity, and air pollution all affect performance. And any failure in a high-pressure system on a road vehicle could create dangerous situations in a completely different way from a regular electric car simply running out of battery. The second challenge is early production cost. Tesla learned this expensive lesson with the Cybertruck. The design was extremely impressive, but the production process was so complicated that it took years to reach meaningful volume. With an entirely new engine technology, the supply chain does not yet exist, parts suppliers are not prepared, and assembly workers are not trained. Early production would almost certainly be more expensive, slower, and riskier than expected. The third challenge is regulation. The United States has an extremely strict vehicle safety approval system. Any new type of propulsion system has to go through thousands of hours of testing and evaluation before it is allowed on public roads. With a technology that has no real precedent, like an electric jet engine for cars, the National Highway Traffic Safety Administration is not going to rush to sign off on approval, no matter who is proposing it. And then there are international markets. The European Union, China, Japan, each region has its own approval process. Tesla once spent months convincing European regulators to accept certain autopilot software features. With a completely new propulsion mechanism, that process could take years. And finally, there is one challenge few people want to say out loud, but it really matters. Musk's expectations sometimes run far ahead of reality. Musk once said fully self-driving cars would arrive in 2020, then 2022, then 2023. Robotaxi has been delayed again and again. The Cybertruck eventually launched, but it arrived years later than originally promised. That does not mean Musk cannot deliver on what he promises. He can, but it often takes much longer than the original timeline. And with a technology as ambitious as an electric jet engine, that delay could be long enough for rivals to find a response. And this is exactly when the race becomes even more intense, because Tesla's not the only player trying to shape the future of the industry. Who is standing on the other side of this race? To properly understand the importance of Tesla's new technology, we need to place it inside a competition that is becoming broader, tougher, and more aggressive every year. Let's start with China's BYD. Not many people in the United States follow BYD closely, but that could be a costly mistake in terms of awareness. BYD is now the world's largest electric vehicle maker by sales. It develops its own lithium iron phosphate batteries, a type of battery that uses no cobalt, costs less, is safer in high-temperature conditions, and has a much longer charging life than traditional NMC batteries. BYD controls much of its own supply chain, from raw materials to final vehicle assembly, and it is expanding internationally at an astonishing speed, from Southeast Asia to Europe to South America. If Tesla changes the basic propulsion mechanism, BYD has both the engineering capability and the financial resources to respond quickly. It is not just a car maker, it is a massive energy technology company. Next is Lucid Motors. The Lucid Air still holds a record for driving range on a single charge among commercial electric vehicles in the United States, even beating Tesla. This is not because of a flashy performance trick, but because of real progress in battery energy density and electric motor efficiency. Lucid is proving that deep optimization of traditional battery technology still has a lot of room left, and that you do not necessarily need to change the entire propulsion system to achieve major improvements. Then there's Rivian, a brand that is steadily building a loyal user community in the electric pickup and SUV segment. Rivian is not competing directly with Tesla on every technical specification. Instead, it is creating a different reason to choose a vehicle based on community, outdoor lifestyle, and practical durability. And do not ignore traditional giants like Ford with the F-150, Lightning, and Chevrolet with the Equinox EV. Ford is trying to put electric vehicles into the hands of practical customers, people who never imagined they would drive a Tesla, by combining familiar design with electrified technology. This strategy is less flashy, but it reaches a group of customers Tesla has never fully touched. So, what does this competitive picture show us? It shows that even if Tesla's electric jet engine really works as advertised, the path to global market domination will not be a straight line. In today's electric vehicle world, better technology does not automatically mean winning the market. Price, distribution, after-sales service, brand familiarity, and government policy all matter just as much in the final equation. So in the end, the biggest question remains: is this technology truly powerful enough to change the future? What could the future look like if this works? This is the part where we step into the territory of possible scenarios, future directions that no one can guarantee for sure, but that are clear enough for us to recognize. The first scenario, and probably the closest impact, is a change in the map of charging infrastructure. One of the biggest barriers to electric vehicles in the United States is not the price of the car or even driving range, but the fear of not finding a charging station when needed. This is especially true for people living in suburbs or rural areas where charging networks are still thin. If the new technology significantly reduces the need for frequent charging or allows faster charging because the total energy needed is lower, this psychological barrier could disappear naturally without the government spending billions of dollars to expand the charging network. The second impact is at the level of mining and the global supply chain. If worldwide electric vehicle production continues growing along its current path, and every vehicle still needs a large battery pack like today, lithium demand will rise to a level that even the most active mining operations may struggle to meet in the short term. This is a real risk for the entire electric vehicle industry. A propulsion technology that depends less on batteries would not only be better for the environment, but also better for price stability and long-term production scalability. The third impact, and maybe the most interesting one for everyday drivers, is the question of long-term ownership cost. One of the strongest arguments for electric vehicles is that they cost less to operate than gasoline cars. Less maintenance, electricity is cheaper than gasoline, no oil changes, no filter replacements. If an electric jet engine is truly more durable because it has fewer friction parts, creates less heat, and wears down more slowly, then the cost of owning a vehicle over 15 to 20 years could shift in a way that benefits consumers far more than today. But perhaps the most shocking impact could be in a field completely outside cars: short-range aviation and cargo transport. Electric aircraft are one of the biggest engineering questions of this decade. The core principle of an electric jet engine applies more directly to aircraft than to cars. If Tesla and SpaceX work together to develop this technology toward aviation, short routes of 200 to 500 kilometers could become electric sooner than any current forecast suggests. And this is a massive market that Tesla has never even publicly said it wants to enter. Musk has never been someone who looks at only one industry. He looks at the whole ecosystem: Tesla, SpaceX, Neuralink, The Boring Company, Starlink. Every project serves a larger vision for how humans move, connect, and survive. If successful, the electric jet engine would not just be a product. It would be a platform that other industries could be built on. And when you look at the whole picture, you start to understand why Tesla's rivals are not just worried about a new car. They're worried about a company trying to reset the foundation of how the world moves energy and people. We have just gone through a pretty long journey, from the big picture of the global electric vehicle industry to the technical nature of a technology no one has fully seen yet, to the potential impacts that could stretch all the way into aviation and mineral mining. But let me sum up the most important point. What matters about Elon Musk is not just each individual invention. What matters is the way he keeps choosing moments to change the rules right when the world thinks it already knows the answer. The electric vehicle industry is in a very strange stage right now, mature enough to become mainstream, but still young enough to be completely disrupted by the right breakthrough at the right time. And if the electric jet engine really can overcome the technical and regulatory challenges we talked about, that disruption could arrive much sooner than many people expect. But here is something no one should ignore. The future is still completely undecided. The history of engineering breakthroughs is not just the story of people with the best ideas. It is the story of people who can turn good ideas into real products, deliver them on time, price them correctly, and convince enough people to believe in them to build momentum. Tesla has done that before, but doing it before is not a guarantee that it will happen again this time. There are hundreds of millions of people around the world, especially older generations in the United States, who have lived through enough big advertisements and grand promises from the tech industry to be cautious. They do not need to be convinced by statements. They need to be convinced by evidence. And that is exactly what Musk and Tesla will need to provide in the coming years. So the final question I want to leave you with is not whether this technology works or not. The question is, if it works exactly as claimed, what would it change in your life? The car you are driving, the electricity price you are paying, the national energy sources we depend on, and more broadly, America's position in a global technology competition that is getting hotter than ever. This is the question I really want to hear your thoughts on. Do you believe this is a real turning point, or is it just another big promise waiting for time to judge? Leave your opinion in the comments below. There is no right or wrong answer here, only different perspectives from people who are truly watching and thinking about the future. If this video gave you a few new perspectives, hit the like button to support the channel. And if you want to keep following in-depth analysis like this about electric vehicle technology, energy, and the breakthroughs shaping the world, do not forget to subscribe and turn on notifications. The race has already begun, and what happens over the next few years could become the most interesting chapter this industry has ever written. I will see you in the next video.